In this lesson, it's going to be very important that you read problems carefully because we're going to look at word problems. We're going to translate them into algebraic equations, and then we're going to solve them. There are some steps listed for problem solving, and number one is to understand the problem. And you will read it and maybe reread it. Construct a drawing sometimes. Propose a solution and check. Pay careful attention to how to check your proposed solution. Now, that one, at least you need to think about what would be a reasonable answer. Choose a variable to represent the unknown. All right, translate the problem into an equation. We practiced this in our last lesson. Solve the equation. We've done that in previous lessons. Interpret the results. This is something that you may really do mentally. It might not be part of your assignment, but you have to look at your answer and see if it is reasonable, and then if you were communicating with someone else, you would have to form a sentence to explain your solution. All right, let's take a look. Let's just jump right in to some problems to solve. The first one. See if I can just make it be the only one on the page. All right, it says 3 times a number added to 3 is 18. Find the number. The first thing I'm going to do is say that I will let x represent the number. Some people don't see that as the important step that it really is, but you need to have a firm understanding in your mind what the variable stands for. Now, every time the problem refers to the number, you know to put down x. All right, going back, reading again, this is the second time. 3 times a number, all right, 3x, added to 3 plus 3 is, there's my verb, that's my equal sign, 18. So I've identified my unknown and I've translated into an equation. Now I'm going to solve. All right, can I simplify on the left? No. Can I simplify on the right? No. Do I have x's on both sides? No. So let's focus on this side. Is there a constant to get rid of? Yes, and I think I'm not going to necessarily use as much color here. I'm going to subtract 3 from both sides. That leaves me with 3x. Those to cancel. Equal sign. 18 minus 3 gives me 15. Now this 3 is the coefficient of x. I'm going to divide by it on both sides. 3 over 3 gives me an implied 1x is 5. And you could check this because 3 times the 5, that would give me 15, added to 3, that would give me 18, is indeed 18. All right, let's look at number 2. The sum of 3, 9, and a number amounts to 29. Find the number. I'm going to let x represent the number. All right, read it again. The sum of, all right, I'm going to be adding 3, 9, and the mystery number amounts to, that's my equal sign, 29. Not a bad translation. Now I'm going to solve this. Can I simplify on the left? Yes. These are like terms. I'll replace that with 12. 12 plus x is 29. There was no simplifying on the right side. Do I have x's on both sides? No. Let's focus on the left side. 12 is a constant. I'll do the opposite, which is subtract 12 from both sides. That's gone. I have x is, when I subtract, I get 17. And you could check that. In MathLab, the only thing you're going to do is type in the 17. But in where you write your notes and take care of your work, you need to show all of this. Number 3. As the problems get a little more complicated, sometimes MathLab will have you select the right translation before you go on to solve it. And that's good. It gives you some feedback before you continue. All right, the difference of a number and 4 is equal to the quotient of 20 and 5. Find the number. All right, x is a number. The difference of, that means I'm going to be subtracting a number, x, and 4, there was no reversing, equals the quotient of, quotient is divide, 20 over 5. It matters the order that you put that. Whatever it mentions first goes on top, and whatever it mentions second goes on bottom. All right, can you, well, I guess that'll do. Can you simplify on the left? No, I'll just leave x minus 4, equal sign. 20 divided by 5 is 4. Are there x's on both sides? No. Focus on the side that does have the x. You have a constant of minus 4, so I will add 4. Add 4. That gives me x is 8. The mystery number is 8. Let's look at number 4. It says 26 less a number is equal to the product of 4 and the sum of the number and 4. Find the number. Now don't get frustrated if you get a little confused as you read that. Read it, begin to write something down. X is the number. Break it into pieces. Let's look at the left side. 26 less a mystery number. Didn't say less than, it just said less. So it's 26 minus x is equal to, okay? I've got the left-hand side. Now the right-hand side is equal to the product of, okay, product, multiplication. 4 and the sum. Please try to remember that when you multiply times the sum's got to go in parentheses, so the 4 will get multiplied by all of it. So I'll put parentheses, x and another 4. That is an easy place to make a mistake. But when you have a number times a sum or a number times a difference, you're always going to need parentheses. I can't simplify on the left, so that stays 26 minus x equals. I can use the distributive property over here. 4 times x is 4x. 4 times 4 is 16. Do I have x's on both sides? Whoops, excuse me, as I have things opening up here. I'm not sure why. Do I have x's on both sides? Yes. I need to get rid of one of them. I'm going to get rid of the smaller one, and minus implied 1x is the smaller. I guess I should really try to use red. So I will add implied 1x, add implied 1x to both sides. That leaves me with 26 is equal to, because those have canceled out, 5x plus 16. All right, now I focus over here on the right. Do I have a constant to get rid of? The answer is yes. I will subtract 16, so I have to do it over here. That gives me 10 is equal to 5x. Still focused on the variable side. The coefficient of the variable is 5. So I'll divide by 5, divide by 5, and I get that 2 is x. You could not possibly get the right answer if you neglected the parentheses. So you would have chosen this one first, and thank goodness MathLab would then give you some feedback. If that was wrong, it would not let you go on to solve the wrong equation. All right, let's look at number 5. It says 40 subtracted from 4 times a number is 2 more than the number. So I'll let x be the number. All right, 40 subtracted from. I don't know if it is standing out to you just yet, but the phrasing less than or subtract from are your reverse phrases. So 40 subtracted from means that the 40 is what's going to get subtracted. What is it subtracted from? 4 times a number. so that's going to be 4x minus 40. There's my is, equal sign. 2 more than is plus the mystery number. Can I simplify on the left? No. Can I simplify on the right? No. All right, do I have variables on both sides? Yes, I do. Get rid of the implied 1x. I choose it because it was the smaller. It's not a rule, it's just what I follow. 4x minus 1x is 3x. Bring down the minus 40, equal sign, 2, and that's gone. Now the side that has the variable, is there constant? Yes. So I will do the inverse, which is add 40. That gives me 3x, that's gone, is equal to 42. Divide by the coefficient, which is 3. And x is equal to 14. The mystery number is 14. So you will have had to choose first. Now, the only one that matched the left-hand side is A. The right-hand side, I have 2 plus x. They have x plus 2. Those are equivalent. With addition, it does not matter about the order. Okay, we have one more. It says 3 times the difference. 3 times a difference. I'm going to need parentheses. Of some number in 5 amounts to the quotient of 99 and 11. Okay, x is the number. All right, 3 times a difference looks like this. The difference of what? Mystery number, x, and 5. Amounts to, that's my equal sign, quotient of, 99 and 11. Okay, and it looks like that will be choice C. All right, can I simplify on the left? Yes, I can use the distributive property. 3 times x is 3x. 3 times negative 5 is negative 15. Equals 99 divided by 11 is 9. Do I have variables on both sides? No. So I focus on the side that does have the variable. Is there a constant to eliminate? Yes. I'll do the inverse, which is add 15. That leaves me with 3x. That's become a 0, is equal to 24. 3 is the coefficient of x, so I'll divide by it. Divide by 3, divide by 3. X is 8. Probably shouldn't have left that in red ink, but I'm not going to go back and change it. All right, we have solved 6 example problems where we translate. There is a single unknown. That's something that all of these problems had in common. The next problems we look at may have more than one unknown.